So the last lesson that you looked at, you would have heard information about perimeter. So perimeter being the distance around the outside of the shape, or the boundary of the shape. This lesson's talking to you a little bit about area. So the idea of area is that it's the amount of surface enclosed by the perimeter, okay, by the boundaries of the shape. So we're talking about the coloured part, okay, for area. It's a two-dimensional measurement, okay, so think flat, and your answers are always going to be in square units, so centimetres squared or square kilometres, square millimetres, etc. Okay. Now, as the name of this suggests, you need to know how to find the area of triangles, quadrilaterals, so four-sided figures, and circles. Now, in your textbook on page 266, you'll find these formulas. Okay, you don't actually get given these in an exam. So these are the formulas that you really need to memorize. Okay, you will have come across all of them before at some stage or other. And if you're unsure on how to use any of these, best that you just check up on that during class. Okay, so we're kind of assuming that you can remember how to use these. Probably the one thing that I just want to point out is that if you have a H in the formula like this, it refers to the thing called the perpendicular height. Okay, so you notice that where there's a H here, it's attached to a right angle. So that's what we're looking for if you're after a H. Okay, and a little clue is that the right angle usually points to the two sides that you need to be timesing together. Okay, so that works for a triangle, works for the parallelogram here, so they're the two sides. Kind of works for the trapezium, except that the formula is a little bit different, but the H is still looking for that right angle. Okay. Alright, so this idea of perpendicular height, okay, so it's the height or the length of the line that is at right angles to the base of the shape. Okay, now the base, that can be a little bit confusing when we're talking about area. It's not always the bottom of the shape, okay, but regardless of that, the height, the base, we're looking for the right angle. Okay, so there's the shapes that we're interested in. Now you need to just be a bit aware with these. So say for example with this trapezium, okay, you might see it turned on its side like this. So you still do need to be able to recognize that as a trapezium. Okay, and you need to be able to find on there still the right angle and the height. So see what I was talking about with the height, it's actually going sideways. So we're not always talking about how tall up and down something is when we're mentioning height. Okay, so always looking for that right angle if you're after the height. Alright, areas of composite shapes. So this is really what I wanted to just do a few examples of. So when we're talking about composite shapes, they're shapes that are made up of more than one shape. Okay, and it's not necessarily always just, say, two rectangles that are next to each other and you have to add them up. Okay, so for example, you might have to find the shaded area of something like this, and it's had a piece cut out of it. Okay, now in general maths, you always need to be looking for little tricks in the question, because these are the things that really tell the markers who actually understands what they're doing. Okay, so with this question, probably the trick that you should be careful of is that these measurements that are given are actually the diameter of the circle. Okay, and when we're talking about area of a circle, we're interested in the radius. So to find the area of the shaded part, the green part in here, we're going to find the area of the bigger circle, and then we're going to subtract the area of the little circle as if it's been cut out. Okay, and what's left will be kind of like a donut, and that shape's actually called an annulus, which you'll learn about that in the HSC course. Alright, so pi r squared for an area. So the radius of the bigger circle is half of 20, which is 10, so pi times 10 squared. The radius of the smaller circle will be half of 12, which is pi times 6 squared. And we end up with an area of around about 201 square centimetres. So just a trick to remember the difference between area and circumference of a circle. When you do the circumference, you're either after 2 pi r or pi d. Notice that like circumference, perimeter, you get just measurements in like centimeters or meters. When you're talking about area, you get square measurements, okay? And the area formula has a squared in it. So that's the way that I remember the difference between area and circumference of a circle. Okay, looking particularly at areas of sectors, parts of circles. So this is something that you may not have come across before, okay? So the angle of the actual sector helps us to work out what fraction of the full circle we have. So this is what a sector looks like, okay? You might have heard it referred to as a piece of pie. So this sector angle in here is 76 degrees, and that's going to actually help us work out the area of this part of the circle. Now this sector has come from a circle that would have looked like this. So you notice that the full circle has a radius of 5 meters, and this sector has, this would have been a radius just here of 5 meters. Okay, so we've chopped it out of here and we've got 76 degrees. So to figure out the area of a sector, there is a formula that you can use. Okay, that's a theta, which is the Greek symbol that usually represents an unknown angle. And that's over or divided by 360 degrees. Okay, 360 degrees because that's the full angle in a circle. So theta over 360 times pi r squared. And what's this one? Well, this is just the normal area of the circle. Okay, so it's just the fraction of the full circle that we've got. So substituting into that, our sector angle was 76 degrees. So it means we've got 76 degrees out of the full 360, multiplied by pi, multiplied by 5 squared. We get around about 16.6 square meters. Now this is something that you probably would do automatically with, say, a semicircle, for example. So in a semicircle, your sector angle is 180 degrees. Now most people know for a semicircle we do half pi r squared. Where does the half come from? Well, 180 over 360 cancels down to a half. So you've probably done this before without even realizing it. Okay, so last example. So we've got here a semicircle placed on top of a triangle, okay? Now this is another problem which has got a little trick in it, or an extra step that you need to do, okay? So to find the total area of the shape, it's going to be the area of the semicircle plus the area of the triangle. But you're going to need to do something here to find the side that we need for the area, because remember in a triangle, half BH, we need to use the sides that have got the right angle pointing to them. Okay, we don't have this one here. So the semicircle there, if we've got half a circle, then it's half pi r squared. Okay, so that sector angle of 180 cancels down to half. And here again, we're given the diameter, so we need to halve that to get the radius. So half of pi times 13 squared. Sorry, those squareds haven't come out very good there. So we end up with approximately 265 square meters. Okay, now for the triangle. So here's that step that we need to find this unknown side. If it's a right angle triangle, we can use Pythagoras. So to do that, because we know the longer side, it actually looks a little different to normal. It's going to be the longer side squared, subtract the shorter side squared, and that leaves us with the other side squared. Okay, sorry, I've changed the number there too, so we'll say that it's 19 meters. So 26 squared take 19 squared is 315, but that's not the last thing. Remember with Pythagoras, you need to take the square root of that. Okay, so the square root of that leaves us at 17.7 meters. And now, if we do the half BH, oh, sorry, I've stuffed this up completely, haven't I? Okay, well you guys get the idea. So half BH is half of this side times this side. Okay, so doing it with the numbers we've got there, we get 159.3. So then, finding the total area of the shape, we add up the semicircle the triangle, and we end up with something like that. Okay?